Hello, welcome back to Pre-algebra with Miss Betsy. Today we're going to be talking about how to find the area of triangles and how to find the area of trapezoids. Of course, first we'll learn what a trapezoid is before we figure out how to find its area. Now, if you are using the same text as I am, we are on page 404 today, which is chapter 12.2. Area of triangles and trapezoids, and we're finding this in our text, which is Pre-algebra for Christian Schools. It's published by Bob Jones University Press, and it is the very first edition that was published. Okay, page 404. You don't have to use the same text, just follow along with us. Now, our lame joke for today says, what did the digital clock say to the grandfather clock? He said, "Look, Grandpa, no hands." The safety of having a computer screen between you and me is sometimes a very good thing. Okay, we learned how to find the area of a parallelogram the other day. And first we learned, of course, that a parallelogram is nothing more than a slanted rectangle. So the area of a parallelogram was simply the base times the height. And you learned that they were always going to indicate the height for us. So this is for the area of a parallelogram. Now, we're not learning about how to find the area of parallelograms today. We're learning about how to find the area of triangles. We learned back earlier that when you're finding how many degrees are in a rectangle, the way you calculate that is by how many triangles you can make out of that object. And the number of triangles that you have in an object is always 2 less than the number of sides. 1, 2, 3, 4. So there should be 2 triangles. We could divide this object up into 2 triangles, and sure enough we can. We can make 2 triangles that way, or we can make 2 triangles by going from this corner to this corner. Now I'm going to refer to my book here so that I get the labels and everything the same way. A, B, C, D, and these letters here represent the vertexes or the vertices. And we're going to draw our triangle, divide our parallelogram into 2 triangles by drawing a line from point B to point C. So we have 2 very clear and distinct triangles. And you remember that you could have the height of the parallelogram was the perpendicular distance from the opposite top right here, if you will, from the top to the bottom, so to speak, of our parallelogram. So this right here is our height. I'll just remember that. Now, if the area of a parallelogram is the base times the height, and we have 2 triangles here that divide this parallelogram in half, what does that suggest to us that the area of this parallelogram might be? Well, would it not be perhaps half the area of the parallelogram? Well, that's exactly what it is. And if you find the area of a parallelogram by saying that by multiplying the base times the height, well then half of that would be the area of the triangle. And that's exactly what the formula is for the area of a triangle. It's half the area of a parallelogram. Okay? What you need to memorize: area of a parallelogram is base times height. Area of a triangle is 1/2 the base times the height of that triangle. Because we're not working here, this is just, they're showing you how we came up with the fact that the area of a triangle is half the base times the height. That's because you can see that very clearly here in the picture, that parallelograms made up of 2 triangles. And what they want to point out to you is, it goes back to that little bit of geometry that we've learned. We have triangle BAC is congruent. Let me see, is that the symbol for congruent? Triangle BAC is congruent to, did I draw my line right? Sorry, one squiggle and two lines is congruent to triangle BDC. What do we mean? Okay, this here. This is for those of you who are looking at this for the first time or who have not yet learned vocabulary. When you have this here, says triangle BAC, identified by the three vertices. Triangle BDC, again identified by the three vertices. This little equal sign with the sort of like the tilde on top of it, that means is congruent to. Triangles that are congruent are the same size and shape. They may be oriented differently. How do we know that these two triangles are the same size and shape? We have two parallel sides. We have two pairs of parallel sides. So we have sides that are the same, and also from the geometry that we learned earlier, the elementary geometry, a transversal bisecting two parallel lines gives us angles that are the same. So angle D and angle A have the same measure. So we know that these triangles are congruent because of the angle side property. This is a review from chapter 11. Okay? So now we're going to rewind here and say, okay, I believe you, Miss Betsy. My eyes have glazed over. My brain is going tilt. Let's not even worry about that anymore. So we have two triangles here that are, we don't say triangles are identical. We say they're congruent. It means the same thing in our world as saying they're identical. They're just oriented differently. So the area of a triangle is half the area of a parallelogram because that parallelogram is divided into two congruent triangles. Now, let's go ahead and see how we work this out in real life to find the area of a triangle. Let's just do an easy one. I'm just going to say we have a triangle that has a base of 2 inches and it has a height of 1 inch. Okay? What is the area of this triangle? The area is 1/2 the base times the height. You always have to write your formula. Area is 1/2 times the base, which is 2, times the height, which is 1. 1/2 times 2 is 1, times 1 is 1. So the area is 1 square inch. Remember, you always have to have units. We have inches. The base is 2 inches. The height is 1 inch. The units are always square, so we have square inches. But most of the time, when you're finding the area of a triangle, you're going to have a picture. And what I need to illustrate to you now, teach to you now, is that a triangle doesn't always sit on its base. So we would think if something's on its base, it's going to be sort of perpendicular to the bottom, not perpendicular, parallel to the bottom of our page, but that's not always going to be the case. Let me read this to you. I apologize for reading every once in a while. You need to. This is the top of page 405. You may use any side of the triangle as the base. The height is always the perpendicular distance from the base to the vertex opposite the base. Study the triangles. Now I know that some of you are going, I lost you way back when you said the height is always. Let me step you through this. I'm going to sketch this triangle here. This is the first one that's in your book. And we have point A, B, C. These are the three vertexes. They don't say vertexes, it's vertices. Vertex A, vertex C, vertex B. And we have this little thing drawn right here. This is the height. Remember, height always has to be indicated that we have a right angle. And we said that the height is always the perpendicular distance from the base to the vertex opposite the base. So we're saying that here, line segment AB, you learned this, AB is the base. So what's going to be the height? Remember, height is perpendicular distance from the base to the vertex opposite it. So CD is the height. You simply have to learn how to see these. They're going to give you pictures. You have to know what's the base. You have to know what's the height. Let's do this next triangle that we have here. Okay, this one sort of looks like this. Similarly drawn. Actually, they're going to be all drawn similarly. Now we have this. We have A, C, B for the vertices. And we have this point D here. Now what did we say is the base? The base of the triangle is where you have that little perpendicular indication. It's the distance from where it's perpendicular to the opposite vertex. So what is our base here? Our base is the line segment BC. BC is the base. And what is the height? It's the perpendicular distance from the base to the opposite vertex. So, line segment AD is the height. Everyone see that? Now, we have one more way that this triangle can be written, or one more way that we can show the base, and it's easier to just redraw it. Okay, except that made it look like I had a right angle there. That's why you have to always have that little square to verify that you have a right angle, because there. We'll draw the triangle like this. We have our same points, A, C, and B, but this time our perpendicular drops down here. So what is going to be the base here? Is it AC, CB, or AB? Well, our base is AB. I'm sorry, the base is AC. Line segment AC. The height is always the perpendicular distance from the base to the vertex opposite. So the height is line segment AB. So go ahead and look at that. Okay. You see how I misspoke? Base is AC. The height goes from right here, which I didn't label. That's D. The height is line segment DB. Let me step out of the picture and turn off this noise. Just kicked in. So you can't just make the assumption that this right here is the base and that's the height. You have to be able to look at your picture. Remember that the base of the triangle is where you have that right angle, and the height is the distance from the base to the opposite vertex. So let's just do one illustration here. I'm going to take this triangle again. And we're going to pretend that that looks like a triangle. We have point X, which is a vertex. We have W as a vertex. Okay, wait a minute. For those of you who have the text that I do on page 4 or 5, they have this as X, W, W. They don't mean that, and then they've got another W here. X, W, X, Y. I'm going to label it this way. Where they're actually working out the problem is correct, but their illustration, they don't mean to have it this way. Say that we have 4 points here. This is labeled as 27 centimeters. And this area, this length here from W to Y is 24 centimeters. The line segment XZ is 27 centimeters. The line segment WY is 24 centimeters. If we want to find the area of a triangle, you have to write for me first the formula that allows you to calculate the area of a triangle, which is 1/2 the base times the height. What's the base and what is the height? The height is the perpendicular distance from the base to the vertex opposite the base. So here's our base, here's a vertex opposite. And the base is only this 24 centimeters. It doesn't include all of this imaginary line here. So our formula would be area is 1/2 the base, which is 24, times the height, which is 27. When you do your arithmetic there, you have that area is 324. 324 is not your answer. Area is always square units. Our units here are centimeters. So the area of a triangle that has a height of 27 centimeters, and that triangle has a base of 24 centimeters, the height is 324 square centimeters. This is how you calculate the area of a triangle. So let's go ahead and talk about what a trapezoid is. We learned last lecture that a parallelogram is a leaning over rectangle. It has 2 pairs of parallel sides. A trapezoid only has 1 pair of parallel sides. So this would be an example of a trapezoid. And the height is the distance from one base to the other. We're going to say we have a base here, and then we have a base here. And the distance from one base to the other is what we call the height of the trapezoid. Know how to spell trapezoid? Trapezoid. Trapezoid has 1 pair of parallel sides. A parallelogram has 2 pairs of parallel sides. Now, what I want you to do is remember, congruent means that it's the same size and shape. You can make a parallelogram out of 2 congruent trapezoids. If I take this trapezoid here, turn it on its head, let me see if I can get a different color here. Turn it on its head, put it in this way. Can you see that I have two trapezoids? You know, those of you who played with, I lost the word, not tanagrams. You would have 6 or 7 or 8 or 9 differently shaped blocks. and you could put them together to form different creatures, different objects. You took this trapezoid block, turned it up, and you formed it, made it to be a parallelogram. These are exactly the same size and shape. So if this is, let me label it base 1 and base 2 the way they do. This is base 1. This is the second, we're just going to call it the second base. Base 1, base 2. The height doesn't even show up because that's just the perpendicular distance between the two bases. When we turn this trapezoid upside down, this dimension over here is the second base. And the dimension up at the top is the first base, isn't it? Hang with me, I have to show you how we come up with this formula for the area of a trapezoid. So, we now have an area of a parallelogram, right? Stay with me here. The area of the parallelogram is equal to the base times the height, right? What is the base of this object here equal to? Well, the area, if we're going to get just the base, that's the first base, b sub 1, plus b sub 2. This is the length of this, because from here to here is b sub 1, from here to here is b sub 2. b sub 1 plus b sub 2 gives us the base of this parallelogram times the height. Okay? That's the area of a parallelogram. Let me write this here in case you're going back. Parallelogram is the base times the height. So the area of this parallelogram is b sub 1 plus b sub 2 times the height. Now, we're not trying to figure out what the area of this parallelogram is, are we? We're just trying to figure out the area of the trapezoid. And just like, in a similar manner to where two triangles make up a parallelogram, two trapezoids make up that parallelogram also. So the area of a trapezoid is 1/2 the area of this particular parallelogram. It's 1/2 the sum of the bases multiplied by the height. You don't need to have that h in parentheses. 1/2 the sum of the bases multiplied by the height. You must memorize this. Area of a parallelogram is base times height. Area of a trapezoid is 1/2 times the sum of the bases times the height. If you don't memorize the formula, you cannot calculate the area of a trapezoid. So let me just pick one for you here to do, and we'll use the actual example here in the book, which is on page 406. We have a trapezoid, 9 centimeters, 19 and 7. "19 centimeters, 9 centimeters, what's our 7 centimeters? That's the base. Remember the base of it's the height. Rewind, the 7 centimeters is the height. The height of a trapezoid is the perpendicular distance between the two bases. This is one base, this is another base. How do we find the area? You find the area of a trapezoid by taking 1/2 times the sum of the bases times the height. you have to write down the formula for me. Now we substitute in. Area is 1/2, doesn't matter which one you call B sub 1, which one you call B sub 2, times 7. Area is 1/2 times 28 times 7. Area is 14 times 7. Area had better be 98. When I look at my book, the area is 98. Is that the answer? No. Area is always in square units. So the area of this trapezoid, which has been given to us with a height of 7 centimeters, one base of 19 centimeters, and another base of 9 centimeters, that area is 98 square centimeters. That's how you calculate the area of a trapezoid. I'll see you again soon.